We're going to do a little bit of review here today. So we've gone through the forms of factoring and how to solve quadratic equations using the different forms of factoring. So here what we want to do is we want to find the roots or the answers or the zeros or solutions, whatever you want to call it. It's all going to be the same thing. We need to find the value of x that is going to work for these problems. In these first four problems, they ask us to find the answer or the root, zero, whatever you want to call it, by factoring. Now, what I am going to do is I'm going to cross off the second one here because we're not going to be dealing with that one. However, 1, 3, and 4, we can use factoring. Now, factoring means I have my equation equal to 0. So I have to make sure that the equation does equal 0 prior to figuring out the x. So if I take a look at this first one, x squared minus 12x equals negative 27. It's not in the right format. It's not equal to 0. So I have to make it equal to 0. So here we're going to move this 27 over because it's the only one on that side. And we're going to move it over to the side with x squared minus the 12x. And we do that by adding 27. Now we can't add 27 to x squared or the negative 12x because they're not the same. However, I can put it at the tail end and we have x squared minus 12x plus 27 equals 0. So here we have a trinomial, which means first we look at, is there any common factor between the three of them? And the answer is no. Here I got 1x squared, I got a minus 12x, and a 27. There's nothing in common numerically that I can pull off of each one. So here we move on to the fact that we can use either the Xbox area model, which I have in a previous video, or we can use the break it down into two binomials. Now, from my experience, most people like that method more than anything. So whenever I break down a trinomial, I know I am supposed to end up with a binomial times a binomial. And I'm still equaling 0. So the question becomes, what are these two binomials? Well, the first thing we need in both of these is going to multiply to our x squared. Now, the only thing that can multiply to x squared is x times x. So we're set there. Now we need to come up with two numbers. And the two numbers have to do two things. First thing, they have to multiply to positive 27. And they have to add to 12x. So this is where listing off of factors of 27 helps. So anytime we have to multiply to a specific number, my recommendation is just come up with the factors. So we have 27 times 1, 9 times 3, and that's all we have. So that is the only possible combination of numbers we can put. We can either put 27 in 1 or 9 and 3. So out of these two pairings, I need to get to that 12x. And the only one where I could come up with 12 is 9 plus 3. So 9 and 3 makes 12. So we're going to put those two numbers in there. So 9 and 3. Now we have to look at the signs in our problem. So we're subtracting 12x and we're adding 27. So we're multiplying to a positive. And the only way I can get a positive when I multiply is either a positive times a positive or a negative times a negative. So the question becomes, which of these two pairs will I use? 9 plus 3 gives me positive 12. Negative 9 minus 3 gives me negative 12. So it's going to be minus and minus. So here we have x minus 9 times x minus 3 equals 0. Now, when it comes to multiplication, anything times 0 is going to be 0. So it doesn't matter if this first parenthesis equals 0 or my second parenthesis equals 0, because whatever this is times 0 is going to give me 0. And 0 times whatever this happens to be is also going to be 0. So we can split this up in using a t-chart. So we'll split it up. In each parenthesis, I will set equal to 0. So we have x minus 9 equals 0. And x minus 3 equals 0. And I'm going to solve for x in each one. So here we add 9 to both sides. So negative 9 plus 9 cancels out. It leaves me with x equals 9. And over here, we're going to add 3 to both sides. And they're going to cross off on this side. So we end up with x equals 3. So here are the two possible answers I can get when I factor this first trinomial. X equals 9 and x equals 3. Now, number 3, we have x squared minus 64 equals 0. So here we only have two terms, x squared minus 64. We are equal to 0, so that setup is good. Now I look at the format. I go down my line. Do I have a greatest common factor that I can divide off of each one? So x squared and 64, the answer is no. No, I don't have any common factor, so I can't do that. Next, I look at the number of terms. Here we got 1, 2 terms in our problem, x squared and 64. Now, if I recall from previous lessons, we had a whole bunch of different options. We had greatest common factor and grouping. Grouping, we needed 4 terms. Difference of 2 perfect squares, where we have 2 terms. And then we have the trinomial, which ends up with 3 terms. So greatest common factor could be any number of terms, and it's just something we can divide off. Grouping, we need 4 terms. Difference of 2 perfect squares, we need 2 terms. If I'm to factor a trinomial, I need 3 terms. So here I see with the 2 terms, I'm going to see if we have a difference of 2 perfect squares. Now, difference of 2 perfect squares, again, if I'm able to do it, I need 2 perfect squares, x squared and 64. We're good there. And as long as we are subtracting, we're good there. So it fits the bill, so I can break this down into 2 sets of parentheses. Now again, anytime I multiply, it's a positive times a negative. So one parenthesis gets a plus, one gets a minus, and then whatever the square root of my numbers or my terms are will go in here. So we take the square root of x squared, which ends up being just x. So that comes first. And then we take the square root of 64. So whenever I take this, when I take the square root of 64, I get 8. So 8 will go in parentheses, and we are equal to 0. So here what we want to do is we want to look to make sure that we don't have any more common factors or any one of these fancy items going on, which we don't. And again, I need to know the value of x that makes this true. So each parenthesis can be split up and set equal to 0. So x plus 8 equals 0 and x minus 8 equals 0. And we're going to solve for x in both cases. So on this side, we do the opposite by subtracting 8. And we get x equals negative 8. And on this side, we're going to add 8 to both sides. They cancel out, so we have x equals 8. So there's the two values of x that make this statement true. X equals negative 8, x equals 8. Now, number 4, we have 5x squared equals 15x. So what we want to do is we want to make sure that our equation is equal to 0, which in our case is not. So first thing, we will subtract the 15x from both sides. It's the lower of the two exponents, so they'll cancel out. Now, I cannot subtract 15x from 5x squared. Even though they both have x, one has an exponent of 2, and the other only has an exponent of 1. So I cannot combine them, but I will put them in order. 5x squared minus 15x equals 0. So from here, I want to go down my line. Greatest common factor, grouping, 2 perfect squares, or trinomial. So first things first, numerically, is there a common factor between 5 and 15? So first thing we do, find the common factor by hitting math over to num and GCD, and we're going to push 5 and 15. So I can divide off a 5. And I look at x squared and x, and is there a common factor between those two, x squared and x? The answer is yeah, both have at least one x, so I can divide each one by x. So what I end up doing is really dividing each guy by 5x. So 5x comes off to the side, and whatever I get when I divide off the 5x goes inside. So 5 divided by 5 is just 1. X squared divided by x gives me x. So inside we have an x. We're subtracting. 15 divided by 5 is 3. And then x divided by x is just 1, so we don't need it. So when we divide off a common factor, we end up with 5x times x minus 3 equals 0. And again, our goal is to figure out what value of x makes this statement true. So any part that has an x, I will separate. So here we can split the 5x and the x minus 3, and I can set each one equal to 0. So over here we have 5 times x is 0, and x minus 3 is 0. So to solve for x, 5 times x, I do the opposite. So opposite of multiply is divide, and we're going to divide both sides by 5. So 5 divided by 5 cancels out, leaves me with x equals, and then 0 divided by 5 is nothing more than 0. So there's one possible answer, 0. And on this side, we have x minus 3 equals 0. We got to move the 3 on over by doing the opposite, so we're going to add 3 to both sides. So 3's will cancel out, leaves me with x equals 3. So here are two possible answers using the greatest common factor method. So the first problem, we use the trinomial. Third problem here, we use difference of two perfect squares. Greatest common factor and grouping, they're very similar. We just divide off common factor in two different groups. Now 5 and 6, we are going to use the quadratic formula and leave answers in simplest radical form when necessary. So when it comes to using the quadratic formula, it's just like the above problems. My equation has to equal 0. As long as it equals 0, we're good to go to use the formula. If it's not equal to 0, we have to make it equal 0. So if I take a look at this problem number 5, x squared minus 5x minus 3 gives me 2. I have to move that 2 on over. It's not the correct method. So we subtract 2 from both sides. So 2 minus 2 will cancel out. Now I can't take 2 away from x squared or the 5x. However, I can do negative 3 minus 2. They're both numbers. So negative 3 minus 2 gives me negative 5. So our equation is x squared minus 5x minus 5 equals 0. So we are now good with the format. Now, ordinarily, we would try to factor trinomial by splitting up 5 into its factors and see if I can get negative 5, which is not possible. So this is where the quadratic formula comes into play. Now, again, quadratic formula is given to you on the reference sheet. You just have to do a quick Google search, or you could save it, or however you want to do it. But the equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a, b, and c are just the numbers that we have in our problem. So we have to state the values of a, b, and c. So a is always with x squared, which in this case I don't see a number. However, there is a 1 in front of it. So a is going to be 1. B is going to be with x, which in this case is negative 5. And c is always the last number, standalone number, which is also, in our case, negative 5. So I will plug in these numbers for a, b, and c in our equation accordingly. So here we have the negative value of b. So negative 5 plus or minus the square root of, and again, b is negative 5, which we have to square, minus 4 times a, 1, times c, negative 5. And this is all over 2 times a, 2 times 1. So now what I'm going to do now is I'm going to go through and simplify this whole thing. So negative, -5, all I end up doing is changing the sign. So -5 becomes a +5 plus or minus the square root. And what I'll do is I'll do everything that's under the square root together. So here we have -5 squared minus 4 times 1 times -5. And I end up getting 45. So 45 all over 2 times 1, which is 2. So here we can't combine. What I want to do is I want to take the square root of 45, see if I get a nice number. Square root of 45. I don't. So what we have here is a mixed number, 5 plus and minus the square root of 45 over 2. So I can't really go farther than that. However, it did say simplest form. So what happens is I can't divide 5 by 2. I get a decimal, so we can't do anything about that. So I'm going to look at what number is underneath the square root symbol. In this case, 45. So what I want to do is I want to break 45 down into its factors to see if any one of the factors is a perfect square. So we have 45 times 1. We have 3 times 15, and we have 9 times 5. So here we look to see, we just found out 45 is not a perfect square, so we can't do that. 3 and 15 also are not perfect squares, so we can't use that. 9 and 5, however, if I take a look at square root of 9, I do get 3. So I can really say that we have 5 plus and minus the square root of 9 times 5, because 9 times 5 is 45. So whether or not I have 45 or 9 times 5, it doesn't make a difference because they're the same thing, over 2. Now, whenever we split things up into factors, I can take the square root of each individual factor. So even though underneath we have 9 times 5, I can do square root of 9 times the square root of 5. Well, we just found out that we have 5 plus and minus, and we said the square root of 9 is 3, and then square root of 5 all over 2. So here we have 5 plus and minus 3 root 5 over 2. That's what's known as simplest standard form, where I break down a larger number under a square root symbol into a mixed number like 3 root 5. So again, I cannot add 5 and 3 because the root 5 is attached to the 3. So it's not the same type of number. So I'm going to leave it as 5 plus and minus 3 root 5 over 2. So there is my answer using the quadratic formula in this problem. Now 6, we have a slightly different scenario. We have 2x squared minus 5x plus 2 equals 0. Now, when it came to factoring up above, we liked the number on x squared to be 1. And even in the previous problem, the number on x squared was 1. But when it comes to using the quadratic formula, we can use whatever numbers we want. So it doesn't matter if we have 1 or 10 or a million on top of the x squared, because we can use the quadratic formula. So again, just like in the previous problem, we are going to state the values of a, b, and c. So a is always on x squared, in this case it's 2. B is always with x, in this case it's -5. And then c is always alone, so in this case +2. Then we're going to use the quadratic equation, quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to substitute in all these values. So here we have the negative value of b, so -5 plus and minus the square root of -5 squared minus 4 times 2 times 2 all over 2 times 2. So negative value of -5, I just changed the sign. So -5 becomes a +5 plus or minus the square root. And I'm going to do everything under the square root symbol So negative 5 squared minus 4 times 2 times 2. And I get 9. So 5 plus and minus the square root of 9 all over 2 times 2, which is 4. So we learned in the previous problem, square root of 9 is 3. So here we have 5 plus and minus 3 all over 4. So now we have this scenario where everything is the same type of number. We all have solid numbers here. So I can actually split up the top. So here, yes, it's plus and minus, but that means we are adding and subtracting 3. So one equation is going to be 5 plus 3 divided by 4, and the other equation is going to be 5 minus 3 divided by 4. So 5 plus 3, we'll do one at a time. So 5 plus 3 and then we divide by 4. So I get 2. And the other one, we do 5 minus 3 and then we divide it by 4. And I get 0.5. And if we turn that back into a fraction, math, enter, enter, we get 1/2. So both forms are acceptable. So we definitely get x equals 2 to be 1, and the other one, whether you have 0.5 or 1/2, it doesn't make a difference. It's the same thing. So there is our other answer, 0.5 versus 1/2. Now, what we do here is complete the square. Now, completing the square is different from the previous forms. The previous forms, factoring and quadratic formula, the equation was equal to 0. Completing the square is the format where it is not equal to 0. So, step 1, we have to make sure it's not equal to 0. So 3x squared minus 2x minus 4. We are not equal to 0. So I have to move. We don't have x's on one side and number on the other. That is the format. X's to one side, number to the other. So here we have to move the 4 over. So we're going to add 4. So we end up with 3x squared minus 2x equals 4. And I'm going to leave a little bit of space here. The other stipulation for completing the square is a has to equal 1. So if I have a number on x squared, which in this case we do, I have to divide everything by whatever that number is. So this means everything here gets divided by 3. So 3 divided by 3 means I have just x squared. I can't divide negative 2 by 3 nicely, so I'm going to leave it as negative 2 over 3x. And again, I want to leave a little bit of space, equals, and then 4 divided by 3 gives me 4/3. So now we're in the correct format. We have x squared, x's are on one side, number is on the other. So now comes the part where we use the method known as completing the square. And whenever we square something, we square it using the number 2. So this means the 2 is going to be our magic number. So our second term in our problem, negative 2/3, will be cut in half. So second term is divided by 2. So all I have to do, we have negative 2/3, and we are dividing it by 2. And we get negative 0.333, which as a fraction is negative 1/3. So we're dealing with 1/3. And then we have to square it. Now whenever I square a fraction, both numbers get squared. So 1 squared is still 1. 1 times 1 is 1. Then 3 squared. 3 times 3 gives me 9. So what I'm going to do is I'm going to add 1/9 to both sides. So we have x squared minus 2/3 x plus 1/9 equals, and then I can do 4/3 plus 1/9 gives me this nice little decimal, which as a fraction is 13/9. So x squared minus 2/3 x plus 1/9 is actually a perfect square trinomial. So this means I have some binomial that I am squaring that equals 13/9. Now the trick is, the binomial is, the first item is always the letter in our problem. So if I take a look at our problem, the letter we're using is x. And when we divided negative 2/3 by 2, we got negative 1/3. So that's the number we have in our problem, negative 1/3. So we have x minus 1/3 squared equals 13/9. So I'm going to bring it on up over here. So we have x minus 1/3 squared is 13/9. So what I want to do is I want to solve for x. So here we got to get rid of the exponent of 2. So we take the square root of both sides because that's going to cancel out the square root and the square. So we end up with x minus 1/3 equals. Now, again, just like with multiplication, I take the square root of both numbers under the square root symbol whenever a fraction. So square root of 13/9 is really the square root of 13 divided by the square root of 9. Now, square root of 13 is not a nice number, so we're just going to leave it as square root of 13. But the square root of 9, which we learned previously, is 3. So we have x over 1/3 equals root 13 over 3. However, I cannot forget the fact that whenever I take the square root of a number, I end up with both a positive and a negative value. So it's really x minus 1/3 equals positive and minus root 13 over 3. And what I'm going to do here is add 1/3 to both sides, because that will cancel out the 1/3. So we have x equals, again, 1/3 is more of a solid number than root 13. So 1 over 3 plus and minus root 13 over 3. So this is technically the answer for our problem, 1/3 plus or minus root 13 over 3. But if I happen to be adding or subtracting two fractions that have the same denominator, I can put the top parts together. So x equals, and then I can combine the top. So I have 1 plus and minus root 13. And then because the denominator is the same for both, all I have to do is put the 3 back underneath. So 1/3 plus or minus root 13 over 3, or 1 plus and minus root 13 over 3. Either are acceptable forms of our answer using completing the square. Number 10 here, again, completing the square, x squared minus 3x minus 4 equals 50. Our equation has to have x's to one side, numbers to the other. So I have to move the 4 over, so we're going to add 4 to both sides. So we end up with x squared plus 3x equals 54. And again, notice I left a little bit of space here. So now that our format is the correct format, x is to one side, number to the other, we're going to use completing the square, where again, magic numbers 2. So the second term is cut in half. So we divide 3 by 2, and 3 divided by 2, we don't get a very nice number, so we'll leave it as 3/2. And then we have to square it. And each number in our fraction gets squared. So 3 squared, 3 times 3 is 9. 2 squared, 2 times 2 is 4. And this number gets added to both sides. So I end up with x squared plus 3x plus 9 over 4 gives me 54 plus 9 over 4. So the x squared plus 3x plus 9 over 4 is actually a perfect square trinomial. So we have a binomial that I am squaring. And again, just like before, the trick is the letter is whatever we have in our problem, which is x. And then the number that we put is whatever we got when we divided by 2. And we got 3/2. So positive 3/2 equals. And then I'm going to do 54 plus 9/4 gives me 56.25, which as a fraction is really 225 over 4. So now that we have the perfect square binomial all set up, we can use our solving methods to figure out what x is. So we have x plus 3 over 2 squared gives me 225 over 4. So what I want to do is I want to take the square root of both sides. That will cancel out the square root and square. So I have x plus 3 over 2 equals, and then I want to take the square root of each number. So we have square root of 225 is 15. And then the square root of 4 gives me 2. And again, whenever I take the square root of a number, I really end up with a positive and negative value. So now I'm going to solve for x by subtracting 3/2 from both sides. So I really end up with x equals negative 3 over 2 plus and minus 15 over 2. So because they're the same type of numbers, negative 3/2 and 15/2, they're the same type of numbers with the same denominator. I can actually do the math involved. So negative 3/2, and then one of them we're adding 15/2. I get 6. And then the other way, we're subtracting 15/2. So we have negative 3/2 minus 15/2. And I get negative 9. So there is our two answers using completing the square. And again, this one's a little bit more wonky than the other ones. You have to commit the process to memory. And again, it is likely that on any Regents exam that they will ask you to use this method whenever you have to show your own work. And we can use any one of these processes in order to solve word problems. So like this one, 2 consecutive positive integers such that the square of the smaller increased by 4 times the larger is 64. So we have to break this down into what we have. We know we have 2 consecutive positive integers, and it says the square of the smaller increased by 4 times the larger is 64. So we don't know what the 2 consecutive positive numbers are. However, we can say x. So x is first number, and x plus 1 is going to be our second number. They go in order, so if our first number is 1, that means our second number is 2. 1 plus 1 gives me 2. Same with if our first number happened to be 4, the next positive number would be 5, because 4 plus 1 gives me 5. So there's where I get x plus 1. So it says the square of the smaller, so the smaller number is x, so we have x squared, increased by, so increased means we're adding 4 times the larger. So this means I have to do 4 times x plus 1 is equals 64. So here we'll use distribution. So we have x squared plus 4x plus 4 is 64. So here is where we want to see what it is that we are going to be doing. Now here we have a trinomial, so odds are we could try to use factoring. So factoring means my equation has to equal to 0. So here we have to subtract 64 from both sides. So we end up with x squared plus 4x, and then 4 minus 64 gives me minus 60 equals 0. So if I were to attempt to factor this, this means I have to come up with 2 binomials. So the binomials again are going to be a binomial times a binomial equals 0. So the question becomes, what are they going to be? So here we have x squared, which is the way we like it to be. So the only way I can get x squared is by doing x times x. Now the trick is coming up with numbers that multiply to 60 but add to 4. So we should just list off factors of 60. Now there could be a lot here. So 60, we have 60 times 1, 30 times 2, 20 times 3, 15 times 4, 12 times 5, 10 times 6, and those are our 6 possible combinations. 60 and 1, 30 and 2, 23, 15 and 4, 12 and 5, 10 and 6. So what we want to do is we need to figure out the one that adds to 4. So 60 and 1 is totally out. 30 times 2, 30 plus 2, 30 minus 2, no way we get 4. Same with 20 and 3. 20 times 20 plus 3, 20 minus 3. 15 and 4, 15 plus 4 is 19, 15 minus 4 is 11. 12 plus 5, 17, 12 minus 5, 7. So 10 and 6 looks good. 10 plus 6, 16, 10 minus 6 gives me 4. So 10 and 6 are the numbers we're going to be dealing with. So 10, 6. And then I have to come up with the signs. So we're multiplying to a negative. So the only way we get a negative is a positive times a negative. And the question becomes, which of these two numbers, 10 or 6, gets the positive? Well, the middle term is positive, so that means the bigger number has to be positive. So positive 10, negative 6. So here what we want to do now is we want to take our binomials, x plus 10 times x minus 6 equals 0, and we want to figure out the values of x that make the statement true. So we're going to split this up and set each one equal to 0. So x plus 10 equals 0, and x minus 6 equals 0. And we're going to solve for x. So this side will subtract 10, and we get x equals 10. X equals negative 10. And on the other side, we're going to add 6. And we end up getting x equals 6. So the thing with this problem is it says we have 2 consecutive positive integers. So if I look at my answers, here we have negative 10. So that's not a possible answer because it is a negative. We need positive. So our first number is going to be 6, which means x plus 1 is 7. So there are our 2 consecutive positive integers, 6 and 7. And we can continue using these different forms in order to find the answer, set up problems, answer questions using factoring, quadratic formula, or completing the square.